The second part of my presentation is dedicated to actually measures to adopt and mitigate climate change in the cities, and we define it as adaptation and mitigation strategies for the cities. And the NBS definition to nature-based solution types and definition, benefits of nature-based solution in urban environment means actually ecosystem service, and the role of NBS in climate change adaptation and mitigation. I was trying to dedicate different parts, and I will start with definition and type of nature-based solution. But before I start, I would like to draw your attention to this nice picture showing us our resources, because we end our previous discussion with the question about the children. So we need to realize that our resources on Earth, different resources, are very, very limited. And as you can see here, these are natural natural drawing. I mean, this is the Earth, this is the water which we have, sweet water which we have available in the form of ice, for example, and these very small dots here, very, very small dots with 160 kilometers, is the water, sweet water resources available for human. So it means that actually our water resources which are available are really, really very, very limited. And we need to treat these resources very specially as really very something which is precious. So coming back to the definition of nature-based solution, we can find a lot of them. And this is very general one, that nature-based solution address social challenges through actions to protect, sustainably manage, and restore natural and modify ecosystems, benefiting people and nature simultaneously. As you can see, the attention is drawn to both society, sustainability, and restore of ecosystems. And more detailed definition is given by European Commission in 2015. And this definition actually determined what we really define as a nature-based solution and what is not nature-based solution, which is also a bit part of my presentation. In this definition, we can read that the nature-based solutions are solutions that are inspired and supported by nature. It means that we, in our technical or eco-technical solution, we follow nature, which are cost effective. This is very important, that a lot of nature-based solutions are actually could run without run. It means not be constructed, but maintains without any cost. These nature-based solutions provide simultaneously environmental, social, and economic benefits, and they help to build resilience. A resilience in the form of adaptation and mitigation as a meaning of kind of adaptation to climate change. So that such solutions bring more and more diverse nature and natural futures and processes into cities, because we still think that nature-based solution could be integrated part in the cities, landscape, different landscape, and sea space. And this nature-based solution could be resource efficient and systematic intervention. And from this last point, resource efficient and systematic intervention means that, for example, one nature-based solution is not a systematic intervention. It's a kind of one intervention which doesn't create a system, which doesn't create, at least in our understanding, a kind of ecosystem or city system or whatever we call it. And here, from the different perspective, we need to look for nature-based solution and other terms which appear in our nomenclature, like, for example, blue-green infrastructure. And it's very important to understand that blue-green infrastructure could be a part of nature-based solution, but they are not the same meaning. So it's very important to understand what is really nature-based solution. So summing up the key factors of nature-based solutions, it's like that they are inspired and powered by nature, addressing social challenges, and provide multiple service and benefits. And among these multiple service and benefits, there is a biodiversity, high effectiveness, and economic efficiency. So instead, looking for this comparison, as you can see in this table, we have these features: ecosystem as a fundamental, biodiversity, effectiveness and efficiency, social and economic benefits we have here, and integration in water cycle, in European water cycle. So this is something which is very, very important. And here you have indicated what is necessary, what is unnecessary. So in nature-based solutions, we have here all these data given as an ecosystem foundation. Yes, biodiversity impact positive, high efficiency and effectiveness, social and environmental benefits comprehensive, and integration in this water economic cycle essential. And in case of blue-green infrastructure, not necessarily all these points needs to be fulfilled. So in case of ecosystem as a foundation, we do not need to look for this ecosystem, not necessary. Biodiversity could be even, as you can see, negative. Effectiveness could be undefined. We sometimes do not look for this efficiency or effectiveness. Social and environmental benefits are a bit, let's say, limited, and this integration used as a components, but not as essential. So coming to some summary, nature-based solution always integrate ecosystem as a principle ensuring biodiversity. Blue-green infrastructure elements may exist with nature-based solution, but do not inherently follow ecosystem-based principle. So we don't need to fulfill in blue-green infrastructure all these ecosystems. And of course, in circular water economy, which is a part of circular economy in Europe, a blue-green infrastructure is an essential part of nature-based solutions. But it's not the blue-green infrastructure, it's not necessary as nature-based solution. It could be a part. And this is very important to understand, to have real benefits of nature-based solutions. And as a part of nature-based solution, we are used to say that we have so-called treatment wetlands. Previous name was constructed wetlands, but later on our scientific group came to the conclusion that treatment wetland is more broader, and all wetlands which served actually all wetlands served this treatment capacity, they should be recalled as a treatment wetlands. So as a treatment wetlands, we have, as you can see here, different type of these wetlands, and we have especially subsurface flow and free water surface flow. Free water surface flow, somebody could say, okay, it's a pond, but later on you will be given information that pond is not a nature-based solution. Pond is a blue-green infrastructure. So this is the difference. So we have subsurface flow, which could be vertical or horizontal. If we have both, if we have one horizontal, one vertical, we have hybrid system. The hybrid system could be also one of the surface and one of free water surface wetland. And then depending on the type of the flow on the left, for example, here for the vertical flow, we could have downflow, upflow, or tidal flow. But I think it's not the point here to discuss very deeply what is the difference between those vertical and horizontal flows, because it's I think our idea today is to give you the broader information, not very in-depth information. And also here, when you look here for the free water surface flow treatment wetland, you have a lot of different type of plants, and depending on these plants, which are the major part of this free water surface wetland, we called them emerging plants, submerged plants, free water plants, and floating plants. So these are general classification of treatment wetlands, which are nature-based solutions. And very, very briefly, here you have free water surface, and very important is to understand that in the nature we do not have ponds, or I used to say to my students, we do not have swimming pools. It means that we have different depth, as you can see here, and we should, if we think about nature-based solution, we should follow this idea. When we change the cross-section, the hydraulic model has changed, and it means that we forcing different processes which occur in nature. If you have a river is never straight ahead. Channel is straight, but river has a lot of deep zones, shallow zone. They are special names, and they are, for example, responsible for different features of the water, and they create different biodiversity. So this is very important to remember, that treatment wetlands follow natural processes. Maybe here this is in Polish, but I hope you can follow this. This is the question here: is the pond or hydrophyte or treatment wetlands? And as you can see here in this cross section, it's very important in our treatment wetlands to follow different rules, to follow the deep zone, as you have here, and it's marked here that we have gray water, it means dirty water. We have shallow zones with different plant species, with different, let's say, boundaries here, which water needs to cross, so water needs to flow through the sandstones and other barriers, and it makes the water to sediment, to filtrate, and different processes are involved here in the purification process. In the shallow water, we have also UV radiation, which works as a disinfection instead of deep zone like we have here. We have sedimentation processes. So if you ask me, what is the hydrophyte, what is the treatment wetlands? Treatment wetlands look like that. If you have pond with the same deep or shallow zone, only one, then it's a blue-green system. So this is the bigger difference, because then you have not so many functions, you have not so many treatment, you have not so many biodiversity. Because if your pond has, for example, deep like this, 1.2 on 1.5, you are not able to have different plant species. So the biodiversity is weaker in comparison to treatment wetland facilities where you have different zones and you can have different biodiversity, a much broader biodiversity, which enhance different processes. So the biggest difference is like that. And coming back to this free water surface, you can have some visualization of different plant species depending on the zones, which are deep or shallow, how it look like. If we come to this constructed or treatment wetlands for wastewater treatment, we used to say in Europe that for wastewater treatment, we prefer to have these subsurface constructed wetlands to avoid potential smell, to avoid potential, bad features of untreated wastewater. So we have at least two types of these. We have vertical and horizontal flow subsurface, and with different dominating processes, because in vertical flow we have dominating processes of organic matter mineralization and ammonia nitrification, which are very important from the perspective of eutrophization. In horizontal flow, we have perfect condition for denitrification and removal of suspended solids as well as organic matter. Now in Europe, we have some already defined design properties in which it is advanced to use mainly vertical flow wetlands or hybrid wetlands where we have benefits of both types, and very important is to use two-stage of this treatment wetlands to have better efficiency, to have better quality of treated wastewater. And very, very briefly, what is the difference between horizontal and vertical flow? In these graphs, you can see horizontal flow. It means that in general, the flow is underground. The water, wastewater, should never appear on the surface. It prevents us from bad smells because people say, okay, wastewater, it must smell badly. It prevents us from mosquitoes because there is no possibility for the mosquitoes to grow. So this is horizontal flow. It's a kind of, from hydraulic point of view, it's a kind of plug flow. And in case of vertical flow, we have distribution on the top. So for a moment, wastewater appear on the top of this wetland and then percolate, filtrate through this sand or gravel, and then is collected on the bottom and release discharge to the recipient. And here, very important, what is nature-based solution and what is blue-green infrastructure. I would say that nature-based solution is when we have plants, when we have possibilities to create biodiversity due to this, that all processes which are occurring during the treatment process are occurring in one compartment. I mean, in this matrix, we used to say that here we have the matrix of roots, matrix of these substrate materials, which could be sand or even better gravel, and wastewater, which is discharged into the system. And all these processes, sedimentation, filtration, biochemical degradation, and other processes as plant uptake occurring in one compartment, in one bed, in this subsurface horizontal or vertical bed. And if we have this system without plants, then it is called treating filters, and we can say that it's a blue-green infrastructure. because we have not so many benefits from the biodiversity, simplifying things. And coming to the benefits of nature-based solution in urban environments and the role in climate change, we need to start with the ecosystem service. I hope that majority of you is already friendly with this. Here I will show you the pipe and rain garden, which is rain garden, let's say pocket rain garden in the containers. As you can see here, you have water from the roof, which is discharged into these containers. And I used to discuss this based on these two comparisons. So gray versus green infrastructure. And here you have this, according to, as you can see, Millennium Ecosystem Service Assessment, which was released in 2005, division into different services, which should be supported by our solutions. And you can see this structure could be different. This is from another sources. But in general, we have 4 functions, ecosystem function. And the first one is provisioning. It means that our system should protect one of these or more than one of different function assigning to the provision service. And this is, for example, food production, water, wood or fiber, or fuel production. And if we look, for example, for this rain garden and gray infrastructure, we can already see that there is no provisioning service from the gray infrastructure. We can wonder how to solve the issue with this provisioning service with the rain garden. What kind of food production could be here? We can say that we can produce here clean water. From the rainwater, we can produce somehow clean water. If it will be not evapotranspirated or transpirated, then we have, for example, water. We can easily say that here we can produce, by plants, we can produce some kind of fuel or some other, depending on what kind of species, plant species we will grow here, we could have this production. Then we have a second function, which is supporting service. Here we have nutrient cycle, soil formation, primary production, habitat provisions. And again, this pipe is not giving us any of such supporting service. Instead, here we can look for these habitats, and in our papers, which I will show you a bit later, together with Magda Kasprzyk, with Dr. Kasprzyk, we assess the biodiversity as a habitat. We assess the biodiversity, and we proven that the biodiversity is in this system really is enhanced by different plant species. Of course, here also we have the soil formation, because the species die and there is a decay of organic matter which we are not cleaning from this, and it means that we produce soil. And if we produce soil, then in next year we have a nutrient cycle. It means that based on the soil our plants are growing. Then we have very important, in case of adaptation and mitigation service, which is climate regulation, flood regulation, and water purification. And here all these functions in rain gardens, for example, in case of this what we are assessing here, we have the climate regulation, flood regulation, because we keep the water in the place of origin. So we are detain and retain, and we preventing the water escape to the drainage system, which of course is much better for the environment. And in the same time, we can purify the water within the material, because we have here different processes like filtration, sedimentation, plant uptake, and other. And of course, spiritual, aesthetical, education, recreation, service. Here you are not able to see, but there are some places to sit here between these green areas. And of course, this is very easy to understand, this aesthetic and educational value of this solution. Here we estimate our rain garden, as you can see, in majority of this regulation and ecosystem service. So we are definitely sure that we have this cultural and supporting, and we're interested in if we have treatment processes in these rain gardens and if we have climate regulation. In the following, I will try to define you this ecosystem service. But first of all, I would like to discuss with you this graph, because it's very important to understand where from we have a problem with stormwater in the city, why we need so much blue-green infrastructure, as it is very common now in the cities. Why we need nature-based solution, it was a bit told in the previous lecture when we discussed this loss of biodiversity, and why we need this nature-based solution and blue-green infrastructure in our cities. So when we look for the history, we have two major driven forces. One is technological development and service deliver function. It means that we start in the Roman time, we start from the aqueduct that ancient Romans discovered that where we have the civilization, when we have the city, it means that we have a pollution. So we shouldn't drink the same water from the place where we are have the city. So they start to bring water from the spring, from the mountains, and everything starts like that. So assess and secure good quality of water. Then in Europe we developed sewer system, mainly separate one, because we noticed that there is a health issue. So here the driven force is increased environmental knowledge and socio-political awareness of societies. It means that societies start to demand from the politician to solve the health problem. After the Second War, more or less, when we start to construct our cities, to make more pavements, more concrete, we notice that we have issue of the flood. So we start to drain and to construct drainage and underground system, because we already have the separate system usually in Europe. So this is the point where our idea was to drain, to collect and drain as faster as possible and discharge water, stormwater from the cities. And then another issue appeared. We noticed that we have some environmental problems, that this water which was discharged from the city was polluted and caused issue with for example, streams and rivers, and this is called urban water sick syndrome, that our streams, which are the recipient of our stormwater, are degraded without biodiversity, they are becoming more channels than natural streams. So then we start to think what to do, and this short period is called waterways cities. And then we have another limits. We have a limits on natural resources, and it means that we need to diverse, fit for purposes our resources. We need to conserve and promote waterways protection, And even going a bit farther, we need to have the adoption and multifunction infrastructure. So it means that we are somewhere here between these water cycle cities and water sensitive cities, when we have integrated, resilient to climate change our cities. And we are still in the front of so-called urban blue-green dream, which I will show you some scheme, I hope. So summing up what we have in our cities, we start with this natural cycle when we have this, let's say, precipitation, then we have a lot of infiltration, small runoff, then we have evapotranspiration and condensation, and this cycle was like that. What we did during our urbanization process, we have the precipitation, very fast runoff and drain through the city without any evapotranspiration, condensation, and infiltration, which is very important. We stopped the infiltration, which means that our resources of groundwater were limited. And what we would like to have, we would like to have this, that we start to have the infiltration, runoff, of course, and start to have evapotranspiration. This is a kind of our guidelines. Here you have the diagram, how it look like in the cities where we have different impermeables, percentage of the impermeable layers, but let me skip of this. What we have now, what is very important, as you can see, this is the paper from 2006, that we finally discover that there is something like urban water integrated cycle. So it means that we have, on one side, we have potable water, we have wastewater, we have storm water. And these are our resources, as you can see. This diagram is very similar to sustainable management. When we have, as you probably remember, we have the economic, nature, environment, and economics. So somewhere in the middle, we have this integrated water cycle, and it means that we have our water which could be fit for our purposes, because we don't need to drink water. We don't need to have drinking water for each purposes in our home, in our cities, in our industry. And very briefly, International Water Association a few years ago issued the principle for water-wise cities. It means, as you can see, different cycles. And let me start with this, that we need to have the vision how our water cycle should look like in the city. Then we need to have the proper capacity and governance. Then we need to have the proper tools for planning. And finally, we need to have adequate implementation. And let me start from this 4 line. This is so-called water-wise communities. As we discussed during the previous part, it is very difficult to do something being one person. But if we have empowered citizens, if we have professionals aware of water co-benefits, finally, if we have policymakers and leaders that are engaged and trustable, we can do a lot. And coming into the cycles, you can see first of all that our cities are in the catchment. It means basin connected cities. So we need to start to plan our water resources based on the catchment. And this is totally agree with Water Framework Directive, which imposed on us the regulation and the basis of water catchment scenario, how we should work in this in the catchment. What are our resources, our needs in the catchment? Then we have this water sensitive urban design. It means that our cities in this green line should be really regenerative, because as you can see in all these points, you have regenerative water service, you have reduced flood risk, you have enhanced livability with visible water, modify and adapt materials to maintain environmental impact. It means here also these different materials with a low carbon and water footprint, materials which could be reused in circular economy, from the perspective of circular economy. And very, very important, this is what we have inside here. This is a regenerative water service. And here we have the first principle, which is replenish water bodies and the ecosystems. Again, we are discussing about ecosystem. Reduce the amount of water and energy which we use. This means that our systems should be energy safe, should be energy mitigation. We should think about this. It means that, for example, here nature-based solutions are really more than welcome. Then we have reuse, recover, and recycle. Reuse, recover, and recycle. So we need to design our regenerative service in this way that we could reuse, recover, and recycle. And also very important is to increase of the system and ensure multiple options. So not necessarily one big wastewater treatment plant, which is very difficult to handle. Sometimes it's better to solve the problem in place of origin. Like, for example, for rainwater management, that we collect rainwater in the place of origin instead of transport water via grey pipe to be discharged. And coming back to this, what is in IWA, we have this water-sensitive urban water balance. And I would like to draw your attention on these two parts. It means that we need to reduce potable water consumption and reduce wastewater discharge. And we need to look for stormwater treatment, reduce runoff, and most likely stormwater reuse, as you can see here, for different precipitation. So this is the meaning of water-sensitive urban design, that we need to use our resources which we have, and we need to increase the infiltration and evapotranspiration. So what we need to do, this is our challenge. So we need to turn from this hard engineering to soft engineering. We need to metabolize pollution on site, in parks, in green infrastructure, in nature-based solutions. So we need to come back to the sources which we have at the very beginning. And of course, it will be quite difficult, and it will demand as a strategy very wise interdisciplinary approach, because probably you will agree with me that now in our cities mainly we have different specialists, and it is very good that we have all of them, like architect, climate specialist, landscape architect, energy planners, urban planners, water engineer, environmental engineer, but they are on a, I would say, separate island, and they are defending its priorities, their priorities. They are saying that architect will say, okay, for me it's the most important how the building look like. And like landscape architect will tell you, okay, but I need this, this, and this. But very important is to act together, to be on a one island together and work together. And this is always very, very difficult because usually we have different backgrounds and we need to understand this properly. And I think it will be my last slide, even if I have more of them. But let me explain. This is so-called example of urban components based on the book issued by and supported by Climate Kick. This is so-called blue-green dream. And these graphs show us different components of our urban landscape, but very important are the places where these elements are placed and the rule. I would like to draw your attention for these different trees we have here, these different greens. It's not because they would like to have different let's say different graphics. It's like that the different shape of the tree, different kind of the tree has different properties, like it is in the environment. So this is a kind of follow nature, inspired by nature. There are of course some trees which enhance pollinators. There are some trees which are giving us better shadow, as you can see here. There are some trees which giving us protection against the wind, like here, Pocket Park, when we could have both shadow and protection of the wind, and also protection against the warm. If it's placed in proper place, we can mitigate the needs of our cooling system. So this is very important. This is very crucial. We are creating the place for rest for the people, so social benefits and these cultural benefits. We have here, as you can see, multifunction green wall. This multifunction green wall could be a wall where we could have both mitigation of the needs for cooling or warming in our houses, or we can also produce, for example, some foods. I don't mean the potatoes or others, but we can produce some herbs or some other very simple, like I don't know, something green to eat in limited version, I would say. We also have some solar heating. We have different, for example, we have stormwater harvesting and recycling, as you can see here. And very important, we are trying to think about groundwater aquifer recharge. It means that we collect water from the roof. We can reuse it directly or we can reuse it indirectly. It means that we are thinking about our resources, about recovery of our resources and regenerative cycle in the city. This, which was in this IWA strategy, that we are thinking how we can reuse water in different sources. Here you have the installation for reuse of grey water, for example, in the city, for example, for reuse for flushing toilets. And of course, green infrastructure, like you can see here, the constructed wetlands for treatment of rainwater, which is, for example, polluted, and we have urban streams and ponds for different purposes. I'm very sorry I was too long, so it left me a lot of slides. But I would like to say at the very end that there are different names for the same idea, as you can see. You can find in the literature water sensitive urban design, sustainable urban drainage system, and idea which is origin from China. It is called sponge cities. But if you look for these graphs, you will see each of items which we discussed, actually, like wetlands, rainwater garden, bioretention facility, green roofs, permeable ground surface, rainwater recycling. So everything which was discussed so far.